And we're live. And this show could be a complete mess because this is supposed to be Polygon Issuance number 111 on August 6, 2016. As I mentioned several months ago, that we would do polygons when we had guests. We are supposed to have a guest. We can't find him. Matt is supposed to be here. He's not here. So it's going to be a fun show now. So prepare yourselves. This is going to be a mess of an episode. But anyway, so what I'm going to do is I'm going to go and search for people as to why people are not around. So let's see. We'll see what's going to happen. But we'll be talking with Caleb Grunsky, who now works at Sims in Norman. But when I emailed him, that's not what he was doing. that's like, oh, he's changing jobs. So it's like, okay. So that's who's supposed to be on. He's right now living in a hotel room. So his hotel, that means hotel internet. And everybody knows, hotel internet's crap. So we'll see how that goes. And my computer decided about 45 minutes ago to freeze. So I don't know why Chrome is acting up. It's been acting up on my mother's computer, and now the first time it's acted up on this one, which makes me a bit suspicious. I don't know why Chrome is deciding to be really bitchy for some reason. But anyway, I don't know. It's being really strange. But anyway, so we'll wait and see what's going to happen with our people that are supposed to be around. So let me see. Well, let me try that. So right now it's actually nice outside. It is not humid. It's decent outside. Better than it being hot, humid, and feeling like crap. And I say that, and I say a word, and then Caleb comes in here in his bad internet.
I think it's better now, actually. Can you hear me?
Yes, I can hear you. Because I've already started, so you're already on live and all over the world, and however many people would want to watch this. So I'm wondering now if I'm going to have to wait for Matt, my co-host, wherever he is, get on.
Okay.
But I'm just blabbing.
Fine.
So anyway, so I found the guest. There he is. He's there.
Okay.
And as I mentioned, before Caleb came in here, he's in a hotel room, and hotel internet's crap. And then that's when he showed up.
Yeah. So, it's better. It's a lot better now than it was before.
And no, it's and I know he's the and you can correct me, Caleb, or if I'm wrong, but no, this kid has graduated high school. He has graduated college. He has a master's, and he's so don't think he looks like Doogie Howser. I don't think Caleb would know what the heck Doogie Howser even was.
I kept saying I look a lot younger than I really am. And I don't know. I kind of like it, but at the same time, I think about
just wait. Well,
just
be happy they think you're younger, because if they think you're older, then it's not as cool. Then you'll want to. So anyway, so while I wait, because I had to look, because the reason when I emailed Caleb the first time, he was at Wisconsin Milwaukee. That because he was finishing his master's. Well, he had to get another job. And then I had to bring up his LinkedIn thing, and he's it's like, oh, and I've done 700,000 things. So if I had to read them all off, it would be about another hour before we'd start discussing. So he's done lots.
I mean, you know, on LinkedIn, you try to sell yourself as much as possible. So, yeah, you put some stuff on there that maybe the most significant thing, but you put it on there just to make yourself look good.
Okay, the first thing he didn't put on here is evidently he didn't graduate from high school, so he didn't do that. He's like, nah, screw that. So, but yeah, he's oh geez, where to start with all this? I mean, he did. Now, the reason I had him on is because Matt, who's supposed to be in here, went to the Severe Storms and Doppler Radar Conference in Nankaning. He went the day, I think, Caleb, you were presenting, which I couldn't go.
What's Matt?
I had a doctor's appointment, so I couldn't go. But
all right, what's Matt's last name?
Chess.
Okay, maybe I didn't meet him, but
there were so many people. I mean, it just made me mad. All the people that were there. It's like, really.
Yeah, they should have definitely went to live stream it, or recorded presentations and post them at least.
Well,
sure, because there was a lot of people at that conference.
Yeah, and I think the only former guest was Tim Marshall, because I have had Tim Marshall. Because I know Tim was there.
Okay.
You're like, yeah, I guess, whatever. Anyway, so, but I know that at least you won the best student oral presentation, which was the Tim Samaras Memorial Award. Tim would be proud. So, thanks. And I'm sure I would take a guess, given that you're in Norman, you've been out to the site.
Actually, I haven't. I should go see it because I haven't been west of Oklahoma City yet.
You're going to have to go because sooner or later you're not going to have the time to do that. So
yeah, I should. Thank you for reminding me. Yeah, I should go see it.
Yeah, because I went to NWA in Oklahoma City, and of course that was in October, and I don't think they had it quite done yet.
No, I think it was done like in December or something.
It was November, December when it was done. That's when I saw an article about it. So, and then somebody was stupid enough to damage it this spring.
Yeah,
stupid as that was.
Pretty dumb.
But we're going off. You were on the dean's list. Yay! You're just, that means you're just smart. He went to South Dakota State. He went to St. Cloud State. He went to Wisconsin Milwaukee. That means he couldn't decide what school he wanted to go to. I'm being facetious. He was involved with he was involved. Well, I'll make a mention because I actually got accepted to St. Cloud State and I turned it down way back when.
Okay.
And you were involved with the Pecan project, the Plains Elevated Convection at Night project, which we could discuss that a little bit. And then you were like at Wisconsin Milwaukee, and now you're at Sims down in Norman doing that. And then I'll have to repeat everything if Matt gets in here. If Matt's no, he's not. So I'm like looking on another window. So because if I had my camera on, you'd be watching my eyes looking at something else. So that's why I have it on, and I want to at least keep my computer going because And this is, and I'll tell this because this is where I'm going off topic again, that I've had this laptop 2 years, not even 2 years yet. I'm on my third hard drive already. So
Oh, wow.
I take very good, I don't take chances with turning 60,000 things on. But anyway, so I use my laptop a lot. So, but anyway, the reason I had you on was your presentation that you did that I didn't get to see in Ankeny about the May 8th, I think it's May 8th, 2009 event. And then we'll just go on with that. That was the main reason, but we can go on about other stuff as well that you've been involved in because there's tons of that. So first off, like we'd always ask anybody, where was the interest? Where did it come from? Because you grew up in Minnesota, so it had to have been something about seeing something in Minnesota to a certain extent.
I just was from a young age. I was really at first when I was little, I was really scared of thunderstorms, and but as I got older, I started to become curious what I was scared about. And at first, I didn't realize I wanted to be a meteorologist. I went to South Dakota State to be a computer software engineer originally. Semester and a half of writing computer programs, I was like, I can't do this life. It's just, I can't do the same thing over and over again. So I thought about what I wanted to do, and just kind of came to mind. State was very close to home, and so I decided to apply there, and they accepted me and started doing meteorology. And as I went along in the program, I realized I liked learning about the weather more and more, and decided to go to grad school. And Norman, yeah, that's basically. I just was curious. I was terrified of the weather at first, but I began to get curious of why I was scared.
Whoops! Well, I'm going to do something wrong. Okay. You'd think I'd know how to do this because I was doing our other show by now. But anyway, so you went as typical. It seems like there's a lot of people that we've talked to, me and Matt, me and Henry, me and a bunch of other people that have been on that have discussed that you went the other direction and then went back to weather after the fact, because you're not the first person we've talked to that's done that. And you won't probably be the last either. Mm-hmm. So when you were taking your courses at St. Cloud State, which is a school that I applied to go to because I liked it, because I'm in Iowa, and I mean St. Cloud State would have been out-of-state tuition. It's not like it's gonna cost me a pretty penny way back when, but that I liked it mainly for the fact that it was a smaller school, more one-on-one, more or less. So I would assume, even though you're a native Minnesota person, that it was more toward what I was thinking too, that it was a nice smaller school, smaller program that has more hands-on one-on-one type thing. Is that what you kind of were going after?
Yeah, I didn't want to go far from home because I was switching majors. I wasn't sure if meteorology was the right choice at the time when I was switching majors, but and then when I got there, my first year, I was a sophomore then when I started at St. Cloud, did okay. I went on autopilot through that year, and then I don't know, the next year I was like, you know what, I got to take this seriously. And the St. Cloud was very nice. It's a smaller school. You basically knew all of your classmates. You got to know the professors very well, and I still talk to them today. So yeah, it's just, and they've helped me along the way. You just know everyone on a personal level much more. Right.
So that's what I liked about when I wanted to go there. I ended up going to Iowa State, but a lot of good it did. Anyway, but that was why I liked about going. Now, of course, and you probably would maybe not know this, that I'm an old coot, because I was going to go. My first year would have been 1999-2000. That was my freshman year. So St. Cloud State was slightly different back then. It was still as small as it is. It was not like, but anyway. But when you did and you graduated with your first degree, what made you want to do a master's degree then?
I knew I didn't want to go into, and I didn't want to go into the private sector. And I really liked school, actually, so that's why I chose to keep going and get paid. When you go to graduate school, you get paid to go to school, so it seemed like a win-win to do it.
So then why Wisconsin, Milwaukee? That's a little further away in this case.
It was, I had applied to a lot of schools, and Wisconsin, Milwaukee is the only one that gave me a full tuition ride. So that's why. Yeah,
that's called. And I just picked you because you're paying. So it's like, okay, I didn't want to make it sound like, well, I didn't get to go here because they didn't accept me. So at least you were truthful and said the right thing. Otherwise,
yeah,
they gave me the better deal. Like, yeah. Like I want. It's like you go where the best deal is, I guess. In your case, you did. So, comparatively speaking, compare St. Cloud State to Wisconsin, Milwaukee. Is there a comparison, or is there no comparison?
Program, I'd say St. Cloud State is a little bit better. St. Cloud State's in a point right now where they're getting involved with a lot more hands-on stuff for the students. It's a little better in that regard. It does not have a graduate program. Wisconsin, Milwaukee defaults to being better, but Wisconsin, Milwaukee has some very good faculty. And my advisor, Mark Evans, was great. I'm not where I am here today without him. So,
and that brings up the thing you did that was the presentation in Ankeny. But we'll get back to that after we're trying to get you to where you are now, which is right now in a hotel room in Norman. Because how did this job all of a sudden appear? Because I'll lay out the groundwork, because I've been following Caleb on Twitter, and he was all about getting his new digs in Milwaukee, and he was all excited about getting this new somewhere, wherever, in Milwaukee. And then he pops up this thing saying, oh, I've gotten this new job in Norman, Oklahoma, and I have to move. So it's like, I'm thinking, oh, good grief. Now he has to start this whole process again. So were you actively looking, or did they come to you?
It was posted in an email. I had received an email saying that this job at the Storm Prediction Center was open, or the National Weather Center was open, and they were taking resumes. It was like a mass email to everyone involved in meteorology. And so then I just decided to apply. I didn't decide to apply. I wanted to apply because it was basically the job I always wanted. And so I gave them my resume, my cover letter, and some references within 2 hours of that email being sent to me. And then I didn't say anything about it because I figured I wouldn't get it, because this field is so competitive, and this job that they were offering was very desirable. So that's why I really didn't say anything, and I didn't hear from him for 2 months until like late June. So that's why I haven't heard anything from them. So I was like, well, I guess I didn't get it, so I better start looking for places to live in Milwaukee and for my self there.
So more or less, from what I gather, your title is, and I'll just make a comparison. you're pretty much at the starting point of Chuck Doswell's career when he first started. Because isn't it? Because it's close to what he did when it was under a different auspices, but it's in the same realm, sort of when he was there way back when he was younger.
Okay.
Yes, no.
I didn't.
Or am I just
know that, Chuck.
blowing your mind? Because
well, I mean, if I had a career like that panned out like Chuck Doswell's, that'd be a pretty good career. So, Chuck. But yeah, that'd be some. That's interesting.
Because he was a research associate at Sims, or the predecessor thing of whatever it was called before that.
Okay.
So I'm assuming that means you're pretty much in the same realm he was when he first came down from, I think he went to Wisconsin, Madison. Yes.
Okay.
After he came back from the Vietnam War. He mentions this lots of times. So, yeah. So now I just blew his mind. I'm blowing his mind that he's now in the same job, sort of, that Doswell had 40 years.
I don't think Chuck got to work with computers way back then. So,
well, the computers were the size of a house back then, probably.
Yeah.
I mean, there were computers, but they weren't very well. They didn't do very good. So, but we'll finally get to where we're going to go. That what I was interested in, the presentation you did, which I think was published, because it says it was.
It's in the process. I'm still making edits to the...
Well, you tell them it needs to be published. About, now I got to look it up, the super derecho. The first thing I was like is, there's such a thing called that. Well, I'm waiting for the super tornado. Oh, wait, that would be any F5 that hits Moore, Oklahoma. I'm being snarky. But it is interesting because I saw that and I was like, how interesting. Because it makes the realm of like MCSs and whatnot, which, as you'd know, because you've lived in Minnesota for so long, and even in the Midwest, because you're not there now, that we have a lot of MCSs in the summer, especially in the summer, especially nocturnal ones, which we seemingly get all the time. We had one, I think it was a week or two ago here, but so go into why you decided to go do a project on this certain event that started in Kansas and then ended up in Kentucky and Tennessee over a period of, I think it was 24 hours or just about then.
Okay. This was this super derecho. It's just a derecho that travels or has some unique, or mainly it's a derecho that has a unique feature about it that's different from all the others. This one happened to have what they call a mesovortex, a really a small circulation within it, and it's like a little low pressure system inside the MCS. But so my advisor had done a paper when he was at the National Center for Atmospheric Research a couple of years earlier, and so he was already very interested in this event, and there's been numerous papers before this studying various aspects of this radio, the environment it formed in, like looking at radar imagery, trying to figure out what was going on. And my advisor specifically looked at the mesovortex itself. Basically, the project he had when I got there was to look at environment and given was this derecho very predictable? Like, could our forecast models produce this thing over and over again, and you know, some offer forecasters confidence that this derecho would happen if it did happen ever again, or is this event just like an anomaly and very hard to test? So that's where my project came in.
Yeah, I'm right now showing the radar reflectivity of the event. So as it starts, and then, well, let me get it to right here. Starts down up here and kind of sweeps through. And not only did I, because I looked at this a few days ago, you can actually see the mesovortex, or a low pressure center, even on the satellite image, because you can see it on the satellite too, which I found interesting, because I can bring that down. Whoops, not that one. Right? See, it's going to show it right there. You can see like the dry slot coming in. So I thought that was really cool on that. So that's, come on, stop sharing it. So that's what so that I was very interested in it because of that. It showed that you are able to predict where an MCS will go, or if it will develop then. Is that what I'm getting the kind of the point at? That's where
yeah, like when I ran my weather model, ran my ensemble, I ran a 50-member ensemble, my forecast model ran for 36 hours. There were 50 different members running forecasts, and the only difference between them was atmospheric conditions at the start of the model run were just slightly different member. So if for slight changes in the atmosphere at the start of the forecast affect whether or not an MCS develops or not, a mesovortex develops or not. And remember, MCS was produced, whether it was weak or strong, but in only 7 out of 50 members, there was a mesovortex. So the event itself had a high predictability for the MCS, but a very low predictability for the mesovortex.
Or for the people that wouldn't know that, the thing that looks like a low pressure center that has an eye, which this one did for a time in southwestern Missouri, which is even more fascinating to the fact that some of these could actually produce spin-up tornadoes. Were you able to figure out it? Because this MCS did, but later on, when the storms were rebuilding in the afternoon, it's mainly straight line. But were you able on your ensembles to get MCSs that could have produced even brief spin-up tornadoes that everybody seemingly hates in the Weather Service, because then they're like, well, you didn't warn us for tornadoes.
I didn't look at most of the tornadoes that were produced in the observed event were along the leading line. And we produced the strong winds. In a low pressure system, the circulation wraps around. You have winds to the south of the low, winds that are south of the low are from the west. So the mesovortex combined with the rear inflow jet of the MCS created very strong winds just south of where the mesovortex was.
Now, on any of the ensembles, was there a difference? High or low is the strongest wind produced on the ensemble, not the observed event, on any of the ensembles that you did of the 50? Was there ones that surprised you that you had to throw out because it didn't look right? Because I assume there's ones that you'd had to have thrown out because they would be like completely unheard of, which probably means
Well, I mean, we kept every member of our 50 members. So, I mean, like we kept it and analyzed it. We didn't throw anything out. We actually used the strongest and weakest members. I used the I used the 6 strongest and the 6 weakest MCS or members that so the 6 strongest that produce the strongest MCS and the 6 members that produce the weakest MCS. Create or I use those to look at the differences between those 2 sets more closely in terms of like and yeah.
So when we, comparatively speaking, what is the difference between, and I'll just put this out there, between a weak MCS and a strong MCS?
Well, first of all, a weak MCS is going to be less organized. You're not, in this particular case, there's going to be less bowed out. There's going to be less bowling structure. Reflectivity, radar reflectivity, also a lot weaker. There was no mesovortex in any of the weak members.
Yeah, I'd figure that. Or it'd be one that kind of dissipates like within only a few hours too. Yeah.
They just had a really hard time organizing it. The MCS had a really hard time organizing itself. Strong.
The stronger members than I would assume were more bowed, lasted a whole heck of a lot longer, like the super ratio, and produced probably wins at or stronger than the observed event. Is that what you saw in your ensembles?
Yeah. I mean, comparing to the observed event, there were like between all members, there were differences between the observed event and what my. So I didn't really look at like surface wind comparisons, like the surface wind in my forecast model was observed, like METAR reports. So I didn't look at anything like that. But I just compared like the general like radar structure to the observed radar structure, and to see if they look comparable in nature. And yeah. Now
I'm reading this here, where it talks about convection in initiation. Yeah, I'll get it out. The CI, which I've briefly heard about before. So discuss what this has to do with the MCS and whatnot.
Okay. So it appears that in the strong members, convection thunderstorms start in northwest Kansas, similar to what that figure you had. They start also similar to what was observed. And then the organize themselves together, form an MCS, and the MCS takes off after that and heads east. Whereas in the weaker members, the thunderstorms develop at like 2 hours later, southern Kansas, and they struggle to get organized, and they just eventually produce something a lot weaker. And those are storm reports right now he has up there.
Yeah. So
the weaker members will get going in southern Kansas, while stronger members will start will develop thunderstorms in northwestern Kansas.
So this is the radar that shows this, and there it goes. And there's where it circulates right there, because that's what I've. But I mean, this is what I saw right here, because you can see this is the event in question, the squall line, and then it curlicues to this eye, which is the mesovortex. And then so for those that would be kind of like, well, I don't know what this means, this would be similar to this being cold front this being warm front, and this is being the occlusion, and this is the eye. So something to that effect. It would be the
Yeah, I
same.
guess you think about it.
It would be the same. I could even do it even better. And probably a lot of people probably would think of this way. Think of this as an overgrown, wacky supercell, where you have the forward flank and the rear flank, and everybody talks about the rear flank downdraft. And that the center right here is the inflow notch, where you would have the possible any type of tornado. But then what's happening is the forward flank is just rain or maybe a little bit of wind. But then it's like the rear flank right here, where you get the strong winds coming on the backside, is the derecho in question. It's like on a more grandiose scale of a supercell. You're just taking it down, or get up and taking it down.
Yeah, the place, region associated with the mesovortex, that was more of a supercellular feature than the rest of the line itself. And where you see the rear inflow jet, the really strong wind values right here, is where it wraps around, where the circulation wraps around on the backside, is where like vortex winds combine and produce very strong very high wind reports. Now, this mesovortex didn't really produce any tornadoes, but it was a very strong winds, or produced very strong winds in combination with the rear inflow jet.
Yeah, which leads to several people always say, and this is going off topic slightly, when they see rotation on radar, you can see it right here, it's on a broader scale, much broader scale, they'll think, oh, a tornado. You don't have to have, you could have rotation even close together, and it could still produce very strong winds. And people say, well, it was a tornado. No, it doesn't have to be. You'll still get strong winds. Strong winds will be enhanced under rotation, no matter if it's a tornado or not. Mm-hmm. And this is a grandiose scale showing that even under a mesolow or a mesovortex, don't get them confused, because I think there's a slight difference, if there is or is not, that you can still get strong winds here, and I always am under the understanding here and then down, kind of at the apex of where the bow is at its the furthest out, is where the strongest winds would be, or at least they're aimed at that direction. Because we had here a couple of days ago where it wasn't an MCS, because, well, you could say it probably was, where we had storms coming in, and they aimed right at me, but then it kind of dove south of me, and I was under severe thunderstorm warning, and we didn't have hardly any wind. We had a lot of lightning, though, but the wind was upwards of 60 to 65 miles an hour just south of me, where it was really bowed out. So, but that was a very small scale. It's not no super derecho, but I wouldn't even say it was a derecho. It was an MCS, nevertheless.
Yeah,
but.
Yeah. Many people we're kind of confused. I think we're kind of in a confused stage about what a derecho really is, or many people are not sure what a derecho is anymore. But there is a actual definition for it, but the word kind of gets thrown around loosely.
Well, this brings back a story, and our guest has watched this show before. I don't know why, but anyway, he has seen the show before, where I talk about an event that occurred here in Anamosa, in Iowa, where I live, back in, I don't even remember when it was, 2014, June 30th, where we had
that day.
Yeah, rotation, and that storm, it was squall line. It was pretty much a squall line, QLCS, but it had tornadoes in it. We had a rotation where, and I mentioned this before because Caleb, he's a smart person, so he would understand this to a certain extent. I was at my parents' house on the north side of town, where I had winds coming out of the south at about 80 to 90 miles an hour, because my parents, of course, my father's since passed away, but the south side of my of my mom's house now was completely covered in grass and leaves stuck to the south side. That we went from a south wind at about 80 to 90 to it was a south wind at like 50 or 60. And then we immediately switched to having a west wind at 80 to 90. Trees were laying completely flat like it was a hurricane. And I had never seen trees do that before. Only one other time had I ever seen that before, and that was during another windstorm many years ago where the winds were way over 80 to 90. And this was probably stronger than that. And there is a picture, which I don't have with me right now, that somebody saw what looked to be a funnel cloud moving over town right before it happened. It was never specified it was a tornado. The town lost a third of its trees. And my parents lost, my parents didn't lose any trees. The trees had to be trimmed, but it was a nasty storm. There's people up and down that swear it was a tornado, but the only damage that occurred was trees. There was very little roof damage, very little. My parents didn't lose a single shingle on their roof, and neither did most anybody else, but there was a lot of tree damage. And I honestly thought for a time it was when you had a strong south wind and then a strong west wind, that it was trying to do something and never could. Because it was on the leading edge where there was a little bump out where the line kind of bumped out, and that bump out went right over where I'm at. And that's probably what caused it. There was like an increased wind. So that brings up back to what you were talking about with the MCS stuff that you've done, that you could have even these little bump outs. And there was even one on that thing, and I can bring it back out. So let me, wait a minute, bring it back out. But I'm going off on this, but I'm rounding it back. So I'm sorry I'm running off because I love to start trouble. So let me bring it back. Blah, 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 here. So what I'm more or less talking about is seeing there's this little bump out sort of right here, because the vortex is right here. But then there's kind of like a bump out right here. So that's where, and you can see it right here. There's a little bump out. The strongest wind is right here. And then there's like here and here, there's pockets. So that's what I witnessed, something similar to this. Now, that was the June 30th, 2014 event. That went from Iowa to Indiana. Nothing compared to Kansas to eastern Kentucky. But it's similar, but not quite as bad. So I'm just pulling off that something similar, but not quite this, I've seen numerous times. But there's some, I would consider that to be a strong, I wouldn't consider it a derecho. They said it was, but it was what I would call a strong MCS. And this is probably something that looks very similar, at least here. Because this was, I would say, at its near mature stage. Because wouldn't you agree to a fact that there's, like in tornadoes, there's stages for MCSs as well, like the development stage, mature stage, the dissipating stage, et cetera, et cetera? Yeah, or is there even a way to be able to describe that?
Development stage, you got your thunderstorm, your original thunderstorms merging together. Your mature stage is basically the MCS's strongest point, and the dissipation stage is the MCS dying. That's about it.
Now, the thing about this MCS, and there's a lot of the nocturnal ones that occur in the summer, typically die out as the sun comes up, because that's when the low-level jet is at its weakest. It weakens. Whereas this one didn't. It kept going and then redeveloped some more storms later. Now, going back to the ensembles, I assume you did this during the same type of period. So how many of them did you see? And I'm talking about on all of them. Did you see them weaken and dissipate during the morning hours, say between 5 and 7 or 8 a.m., and how many of them continued on, and were those the strong ones that continued on past, say, 7 or 8 o'clock in the morning?
Let's see. Hang on, I believe there
I
were.
cause a lot of trouble. I'm doing good questions.
That's fine. I believe. Look at timestamps. It was at its strongest point in the early morning hours. Let's see. Yeah, 12 UTC is when, which is 7 in the morning.
7 a.m. Central.
Yeah. Yeah, so that in my ensemble, that's when the MCSs were the strongest. And, they started to weaken as the day wore on, but during the morning hours, that's when they were at their strongest point.
So you would consider, based on what you did, that the strongest MCSs would be its strongest after sunrise, which is somewhat interesting, but not unheard of. At least, because I've seen several that have kept going, and I wasn't too happy because I had to do severe thunderstorm warnings. But anyway, and posting them, I did not like staying up for hours and hours and hours because there was an MCS. Oh, it's gonna die. No, it didn't. So, yeah, I figure, because there's and I'm going off on a tangent again, so I'm sorry. Anyway.
That's fine.
Yeah, I just ramble. I might as well call this show Ramble, because that's all I pretty much do. Anyway, so you did these ensembles based on the event in May of 2009, May 8th.
Mm-hmm.
Could you take this into consideration for storms, say, anywhere else? Not in western Kansas. Let's say the western Dakotas, and have them sweep through Minnesota, Iowa, into the Great Lakes, and going all the way to Pennsylvania, say, for that example.
Yeah, I mean, like, you could do, as long as it's an observed event, like it actually happened for my model setup, just to change the date, change the date, change where your model domain is. In this case, it was over the central United States. If you want to move it, you just move it to wherever the observed event happened and change the date, and that's all you need to do, and you can do the same research on a different event.
So now that you're down in Norman and doing work, what are you wanting to get out of this job that you have now, besides not being in a hotel room?
I want to see like what I can learn here, and I want to stay here. So I'm hoping that this job leads me to more opportunities here.
Meaning he wants to be a professor at OU. He wants Howard Einstein's job.
Well, I need a PhD for that, and I'm not exactly sure. I mean, I was going to go for it if I didn't get this job, but now I'm a little on the fence about it. But I want to see where this job takes me. I want to stay in Norman, and yeah. So
you don't want to be the next Dr. Timmer.
not going in tornadoes. I'm not much of a storm chaser. I do it from time to time, and it's not something I do.
Well, I mentioned because there was tornadoes up in Minnesota, around just down from St. Cloud. You know which ones I'm talking about. So, and you were talking about those, and everybody was chasing them. It's like, really? It's like, geez. So, I mean, and then I read a thing today, because I'm going off topic again. This is in reference to something that happened in Iowa back in, and I'm going to bring it back up because I saw this. This came out today from Kevin Scow at the Weather Service Des Moines. And this would be something to discuss before you have to do whatever you do in a hotel room. And I got to bring it up. So just a second. It was about an event that I now can't find because they moved it on me. Those mean people. Come on. I saw it, and now I can't find it. Come on, give it to me. Oh, figures. It wants to be. Let's just a minute. I gotta find it in my history. It was about. It's not going to tell me, is it? Come on. No, I don't want to see Caleb's other 500 Google Plus accounts. Because yes, I found a bunch of them.
Two, I believe.
Okay, here it was. This is from stupid gnat that's in my apartment. That this was from August 31st, 2014 in Iowa. And this was from Kevin. Yeah, this was on the Weather Service's blog from Weather Service Des Moines. It said, how many tornadoes can one squall line produce? What did they find out, supposedly? According to this, and now I'm being messaged. Why am I being messaged? Okay. Anyway, so, but they found out with this, and I'll do this. So let me bring it back up because this would be interesting. So so just a minute. I got to screen share this. It shows, and right here, that they did the squall line was measured with photography, and it found 111 discrete damage tracks that could have originated from a tornado. 111. Get out the pieces of paper. You might be doing research. This might run up into MCSs with these type of events. Of the test, they found that 35 of them were actual tornadoes in Iowa. That would mean, if this is to be correct, that would make it the worst tornado outbreak in Iowa state history. And it occurred in a squall line. Oops. That sounds like not good. So, no. But see, here are some of the tracks. I mean, yeah, they show this. This is where we're coming to today. Would you have seen any of these back 5-10 years ago? No, because the technology. Because technology is getting much better now.
Well, so, yeah, I mean, not until you did a flyover of farmland and saw that those things were in the field. Those tracks were left behind. But imagery or better radar imagery definitely helps identify those. But even now, it's really hard to warn these types of tornadoes that spin up really quickly and only last a short time. Usually, weather services really struggle with these types of tornadoes because they'll spin up real quick and they'll be gone within a frame or two. So, yeah, I don't know how you warn them.
And they mentioned that you can't warn for stuff like that, but it brings up back to your point of doing your research with MCSs and these super derechos that do we know technically, because that was back in 2009. Here was an event in 2014 that was kind of like it's like an afterthought. It's like, oh, August 31st, 2014, who cares? I'm not going to do a research project on something boring. And they did, and they found what could have been 35 tornadoes and 114 areas, or 111, it was 111, that were suspect. Mm-hmm. That sounds like a research project on how many tornadoes do squall lines actually produce, and then build it up to MCSs, derechos. All of a sudden, derechos go from Kansas to Kentucky, Tennessee. All of a sudden, you're going from 111 to possibly 5, 6, 7, 8, 9, 1,000 or so possible. So all of a sudden, you're getting to are tornadoes really rare, or are we just not, or they're just not lasting long enough for us to see them to a certain extent?
Well, I mean, not all squall lines or MCSs are in environments that are capable of producing tornadoes. There are differences within the environment of an MCS that can produce tornadoes and MCSs that cannot produce tornadoes. So it's not like all the MCSs are the potential to produce many tornadoes or any tornadoes at all. So
for example, and I'll probably use an example that typically nocturnal events would not likely produce tornadoes. Not always, but more not likely, because it's and typically also complex type MCSs, because if there are frontal systems where there's like a lot of wind shear around, yes, but there'd probably be an enhanced risk if it's like a cold front, a warm front, any type of boundary. But if it's like a complex that's rolling in, no. So
that I agree with the nocturnal. Usually at night, a certain near surface air is stable, so
because all the cape
is
gone and there's no energy on. Yeah.
Well, there's cape, but it's not from the surface. It's where the cape starts.
Because that leads to what is commonly known as the elevated convection, which typically means no tornadoes. Because if it's elevated, you're not going to get anything tornadic. That's where you get, as I call it, the UFO clouds. The clouds that are nice and cool. Because I've seen
surface-based storms can still produce those clouds.
Yeah. During the day, because I've seen them during the day when there was rotation, but it never produced, and I was not upset because I have never seen a tornado. I've seen funnel clouds. I've heard a tornado at night from close distance. So I don't want to see. Especially when I was in my apartment when I was living in Cedar Rapids, big city. Here comes tornado comes through at 11 o'clock at night. And it was an F2. No, thank you. I heard it. I don't want to hear another.
No, not a city like that. That's a bad situation for a significant tornado.
Yeah. So and that was not an. I'll mention from that day that was supercells at night, which was a little strange. It's like kind of a broken squall line, which broken squall lines you might as well not even call it a squall line. It's supercells. Or something multi-cell. Anyway, I went off and rambled about that for a while. So I just had to kind of get all that in. So outside of that, typically I talk about anything interesting that happened in weather across the country. Probably the tornado near Omaha that everybody must. I don't know what it is. And I'm sure you've seen the picture of what the skinny little rope tornado, which was a water spout at Lake Manawa. How many people I had to crack them? They said, it's in Nebraska. It's like, no, it's not. Lake Manawa is in Iowa. Because it was
I saw that too. And the plane landing at the airport with the passenger taking the video.
And it's like, look, there's a tornado on the right. That sounds like Omaha to me. They don't call Omaha doesn't call their minor league baseball team the Storm Chasers for nothing. It's like, you don't even need to go. They just come to you. So, but everybody talked about that. I saw so many pictures of that tornado. It's like, oh, there's a tornado. Let's drive to it. How many people actually, I heard, drove to the lake because the tornado stayed at the lake? It never moved off the lake. It just stayed there for 10 minutes. People actually drove to the lake and took a video of it and took pictures.
That would be something to see. I mean, it's the same thing as storm chasers, where they drive to go see storms. I mean, if there's a tornado, if there's a water spout just sitting there, not moving anywhere, mean, I'd go look at it just to see it.
It acted more because it was if it had been out on land, it would have been a land spout because it had the features of a land spout. But it acted like a land spout or water spout, where it kind of appeared, it kind of just moved, and then it kind of died out. I think from what I could see from video, I saw a drone video of it when it died, that it looked like the rain that was to its east, that the flow from the cool air coming in from the rain killed it. And it kind of dissipated really fast from the middle up and down. That's how it died. But they issued a tornado warning, and then 3 minutes later they canceled it because the storm wasn't severe. It was just a typical summertime pop-up thunderstorm. It just happened to produce a tornado. It happened to be seen by hundreds of thousands of people, and then it went away. It was the only tornado in the state. It wasn't the only tornado warning, because there was a tornado warning near me later that night. That was from two outflow boundaries merging, and then we had a little curlicue at the merger point, and it lasted about 7 or 8 radar scans, and then it went away, which looked like something suspicious. So outside of that, I got a lot of rain. It looked interesting. I mean, that's all that happened there. I assume nothing exciting happened there, weather-wise, in the last few days.
Here in Norman.
Yeah, in Norman.
It's just been really hot. It's not really enjoyable. You walk outside for a couple of minutes and you're just sweating. So I'd definitely go for some storms right now.
So I'm not going to make a mention that right now the temperature today didn't even crack 80. Because it's the nicest it's been in a while.
It's just
go ahead.
90s for a week straight, and it's just not going to stop. So yeah, I'm jealous of your 70-degree weather.
Yeah, and that the dew point is, I think, in the low 60s or in the upper 50s. Because I'm probably going to open my windows tonight. Because I have my air conditioner on now only because the sun bakes into my apartment, because I have a west-facing apartment. So the sun just bakes right in, so the temperature warms up. So, yeah, it's nice outside, but if there's no breeze, which there's a little bit of a breeze, but not enough to cool my apartment off, I still have to have my air conditioner on regardless. But it's so nice to be able to drive, because I drove up to Dubuque today and not having to use the air conditioner, having the windows open. It was wonderful. Nice flat top clouds, flat top, flat bottom cumulus clouds all over dotting the sky. It's like the typical summertime that you wish it was all summer, but then it's like 95 and dew point of 80, and then you don't like it anymore. And we had that a couple of days ago where we had dew points in the 80s, and it was horrible. You would know, having grown up in Minnesota, dew points in the 80s are not fun.
No. I mean, we usually get that. I get like a feedback. Who's it? I believe it's yours. Yeah, I'm getting feedback off you. Or I can like hear my voice through your microphone.
Yeah, just a second. Let me fix that. So just a minute. Okay, let's see if this works.
So what were we talking about? In Minnesota, we didn't get the 80-degree dew points hardly, like very rare. So when it did happen, it was pretty miserable and just stayed inside for the day.
Yeah, this has me going back to the horrible summers of the 90s, way back before your time.
I was born in 92, so.
Yeah, well, I was born in 1980, so I'm an old geezer. Anyway, 1995, I remember that summer really bad because that was a horrendously humid summer. 1999's summer was horribly humid, where it's like in the mid to upper 90s, dew points are in the 80s, heat index over 110 to 120. No, thank you. I did not particularly like that at all. And a few weeks ago, when we had temperature of like in the 90s and a dew point of 82 or 83, and we had a heat index of about 115, it made me think of that summer of 95 and the summer of 99, which were horrendously humid summers. At least it's not 2012, where it's a drought, it's 106 outside, but there's no dew point. But I think a lot of people...
Yeah. Go. What were you going to say?
So,
Hello?
I don't know if we're... Yeah, hello.
You there?
Can
you hear me?
Okay, are you? Yeah.
Yeah, I'm there.
Okay. We might be slightly delayed now, so
Okay.
maybe. I don't know. We're confused. So, anywho, so people complain, oh, it's like the heat index is 115, but then they'll want it to be cold, and then when it's 10, 20, 30 below zero, they'll want it to be hot. So, I mean, you take what you get, I guess. So.
Yeah. In winter, when living in Minnesota, you want winter to come. At least winter was my season, but I'm starting to get to the point where I'm not liking winter that much anymore. And when it's like 30, like when it's like 20 degrees, 50-degree day, I would be very happy with.
Just wait for one winter in Norman where you have like 6 or 7 ice storms, and you'll not like that either.
Well, I was talking about people that have been living in Norman, and ice storms are not. They do happen, but they're not extremely common. It's not like you get ice storm after ice storm. But I am kind of nervous to see what happens when we do get an ice storm here. Experienced a couple of ice storms, but nothing really bad when living in Minnesota. So, yeah, that'll be interesting to see.
Well, the best thing for you would be that you grew up in Minnesota, so you know how to drive. The problem is people in Oklahoma don't, and they'll crash. And
yeah.
you better hope that you have an apartment where you can walk to work.
That's unfortunate because I don't have an apartment where I can walk to work. But
yeah, too bad.
Usually, when snow and ice happens, they usually just shut everything down because they don't have the equipment. Like the highway departments don't have the equipment to deal with, so they just shut everything down for a few days. Or
they do
until things get better.
Or because I know this for the fact that in I think in northern Oklahoma they'd have more of the equipment than say OKC or even Tulsa. Tulsa might have more equipment than OKC when it comes to winter because of it being slightly further north, and it's slightly hillier, slightly. I've driven through Tulsa and I've driven through OKC. I wouldn't want to live in either place. It's okay to stay. It's okay to visit, but to live there, it's after tornado season, it's like heat season, and then after heat season is cold season, and then cold season is tornado season. So there's 3 seasons: heat, cold, and tornadoes, and that's about it. There's not much else.
Yeah, like their definition of cold down here is like
60,
40s. So Yeah, like I was talking to the person. She was like, "If it gets under 45, I'm cranky because it's too cold." It's like that's a good day in the winter. Like I'll take that any day in the winter.
Yeah,
Yeah,
I'll take. That's the only thing about Oklahoma is that there's no winter.
no.
It's like, but which you'll like to a certain extent. Then if there's an ice storm, and then you won't like it. So we'll see. Where if you want to look into the future, where do you see yourself in, say, 5, 10 years? Being Chuck Doswell, getting a PhD, running something, running the Weather Service, taking Rick Smith's job, taking Greg Parvin's job.
I see myself SPC. I want to at least be still at SPC and moving up in the ranks, slowly gaining more responsibility by doing good work, and who knows what will happen. Um, I'm just going to take this, see where this job takes me. And so I guess I'm excited for, because there's a lot of opportunities now that are available or that could become available.
Well, we hope that because their SPCs, I think, going through a recycling phase because a lot of the forecasters are nearing the retirement. So you might get to be one of them. I don't know if you'd want to do that. Would you want to do that?
It'd be cool to like fill in, and I don't know if I could forecast severe weather every day, like, just keep doing it over and over. I don't know if I want to do that. And it's like figure out how to better, or like figure out how the weather works and how to better forecast it than just forecasting. But it'd be cool to fill in, like get to be able to like do it once in a while. That'd be something cool to do.
So since you would be there, would you be able to do like a simulated thing of doing an outlook, but it's not put out? It's like a simulated type thing to see if you could do it. I mean, they should try to do that, to try to get as many good forecasters in there.
Yeah, I mean, I could do it on my own time if I wanted, and then just verify about like against what they do and the actual storm reports. I think though they just, they get. I don't know how some of the other like research associates, or there's people within my office that will fill in for the forecasters from time to time, even though they are like specifically researchers. So I'm not sure exactly how they get if how they go out gaining experience, or if they're just like asked one day, "Hey, come in and fill in for us. We need someone."
So there's a chance that it could happen, but it might be a ways down.
Yeah, I'm not seeing like myself being fill-in forecaster anytime soon, but it'd be cool to do eventually.
So would you want to do anything else? Would you want to be a professor? Would you want to? So you just want to stay at SPC and not go into teaching and all that stuff?
I do like teaching. And being a TA in grad school, it was fun interacting with the students
and telling them off.
Usually not nicer than that. Otherwise you get in trouble. But I do, and I would like to start working with radar, learning more about it, because it is something interesting, and I do like doing research from an observation standpoint rather than like using just strictly computers. So it'd be cool to start learning more about radars and being able to work with them, which is also, as you know, Oklahoma has a lot of radar technology. So
yeah, because they have so much radar. They don't share with others. So other than that, we don't have anything else that I can think of. I mean, if I come up with other stuff, well, I'll have you back on again. But then by then you'll probably be like, no, Noah's not letting me. I have to then talk to Dr. Ussolini and all this stuff. And Ussolini was at this thing in Ankeny too, which really made me more mad. Because I know he's going to...
What?
No, I was going to let you...
What?
We're interrupting each other.
No, Ussolini, if you ever do get the chance to talk to him, he's a very nice guy. Busy, he's very busy, but he'll take the time out to talk to you. I didn't get a chance to talk to him at the meeting either, but I did meet with him at a previous conference. I got to talk to him then, but he's really nice. So,
I know he's going to be at NWA in Norfolk in September. A thing I'm not going to because of a certain thing that I can't mention publicly. But anyway, so outside of that, if anybody wanted to get a hold of you, wonder why you still look like you're 10 years old, etc., how can they do so?
Twitter. My Twitter handle is my first and last name, Caleb Grunsky. My email, I have 3 email accounts. You
better give the Noah one would probably be the one you'd want to use now since you're in a government entity now.
Yeah, I guess so. Caleb.grunsky@noaa.gov. That's simple. I don't use Facebook much anymore. I do go on LinkedIn once in a while. So I do like social media, and Twitter is probably the easiest way to get a hold of me. So yeah.
So, and for the people that have been on, if you see Patrick Marsh, because he's been on the show before, because I had him on. This was funny. I did 2 of these shows back to back on the same day. Oh. Patrick Marsh was one, and then I had a winter weather preview with 3 other people. Oh, it was a mess. And then by the time I was done, 4 hours of talking, it drove my voice to insanity. But I know, I assume you've probably have seen him, or if you haven't, you'll see him.
Yeah, we've talked to him.
Because
Patrick's a funny guy, and he's really nice. Yeah,
and his newest child, his wife was just about to have it when I had him on. So, the funny thing is, his show, he was driving home. He went from work to home while he was talking with me. So you're lucky you're in a hotel room and not in a car. And I'm sure everybody's wanting to know why am I going off, because I'm rambling again. So thanks everybody for watching this craziness, because we'll see when we get another one, because as I said before, that when we have a guest, we'll do a Polygon, but when we don't, we'll do the other show. So we'll see what happens next week. And Matt did respond to me. He had an emergency, so that's why he couldn't be on. So that's what was going on earlier. So thanks everybody for watching, and we'll see you next week with whatever show we're going to do, because I don't know. So goodbye. Say goodbye.
Thanks for having me.